All right, good morning, folks. Today we're going to have a couple of things that we're going to do before we really get sort of started into the lecture. The slides themselves, of course, are located on Blackboard, so you can head in there, go to the lectures section, week 1, and then you'll see lecture 1B. So those should be available. Typically, when I put them up, if you saw the ones from Tuesday, you'll see that I put them in sort of the 4-panel mode. So that way it takes up a little less space if you want to print them off or you want to sort of annotate stuff on them. But if at some point you do want the sort of full sort of style that I'm presenting here, you can certainly let me know. So today, to sort of start off, I'm going to let Dan give a little intro. There's a tutoring service available specifically for CS1 and a few other sort of intro classes, like some of the math classes and stuff. So we have an embedded tutor, Dan. So he will be our tutor. Typically, he'll be here during the lecture time and, from what I understand, during the lab times as well. So he can help you guys out. If you have questions and stuff, you can definitely ask him. He is a student at Wentworth, just like you guys are. So particularly if you don't feel maybe as comfortable asking me certain questions or something, he is here to help you. So I'll let him give an intro, and then we will get started into the lecture. So Dan, take it away.
Hey everyone, my name's Dan Tran. Pretty original, right? I'm a second-year CS student. I was a tutor that was assigned to this class, so I'll be looking forward to working with you guys this upcoming semester. That's all I had, Professor.
Okay, great. So there are tutoring sessions, sort of drop-in, drop-out tutoring sessions available as well. So I'll put some of that info up on Blackboard for you guys. Typically, from what I understand, they are Monday and Thursdays.
Yeah.
So with our assignments being this is a question that I think Emma asked on Tuesday. With our assignments being given on Thursday and of course due the following week, you should be able to go to several of those sessions if you need to. So the tutors that are going to be there are there to help you with your assignments or with just general practice stuff. So I'll put that information on Blackboard. You may have gotten emails about it, but I'll make sure that it's available to you guys directly as well through our class link. I highly encourage you guys to go to those when you're having issues. Obviously, I'm here to help as well. Dan will be here, but seeing some of these concepts from potentially a different perspective is also very useful. So some of the other tutors, some other resources potentially online as well that I can certainly direct you to, potentially can get you sort of learning this stuff maybe a little bit better, maybe a little bit faster, that sort of thing. So I highly encourage you to take advantage of these resources. They've really done a good job setting this up during our sort of online learning thing. So I highly encourage it. Paxton, did you have a question?
No, I didn't.
Okay, that's right. I saw you were unmuted. I wasn't sure if you were waiting for me to be quiet for a second. Okay, so for our introduction to computing, I have a little bit of sort of history type stuff to start with, but one of the things I wanted to show, I actually dug this out of my closet just recently, and I just wanted to show this real quick. This was actually the computer that I learned to program on years and years ago. The first language that I had ever learned. This is a VTech pre-computer power pad, and it's not an actual like real laptop. It has a screen that is 4 lines in size, and it had a bunch of modules, a bunch of like learning stuff. It's one of those sort of learning computers from like the 90s, basically, that kids would get a hold of, and it's just a little LCD screen that only shows text, that sort of thing. So obviously, we've come quite a long way. Eclipse is quite a bit better than using 4 lines to learn to program, but a lot of the concepts and the instruction manual for this pre-computer power pad, most of it had some stuff about how to use the computer itself, but most of it was learning BASIC. So it was the basic programming language. And the funny thing is, flipping through that manual, it's a lot of the same concepts. They use the same terminology. Yeah, the syntax is different. But overall, learning something like BASIC, learning essentially any language, gets you right into potentially learning even more in the future. So even though I started with something that just had a 4-line screen that was not that great in terms of helping me to program, it's really come a long way, but the language stuff is all very, very similar. So that's something that that I wanted to point out. I actually haven't brought that to campus yet, so I haven't showed it off. So if you're interested in the pre-computer power pad and that sort of era, there's lots of information about it. But that was a long time ago. The funny thing is, it actually has a mechanical keyboard, which is something that I had totally forgotten about. So something that was sort of around and then disappeared for a while, and is sort of making more of a comeback for certain types of programmers and gamers and stuff. Okay, so let's jump into the lecture. So I want to do a little bit of history first. And when it comes to like computing devices, things that we use to actually do some kind of calculation, we can go really far back. So if we just think sort of calculator-wise, something like the abacus is something really far back, but it's really a computing device. Yes, it's only a calculator. Yes, it's sort of abstract in at least nowadays, it's a little abstract as to how it works. But it was one of these first sort of computing devices that lets you store values and then use those values to help you do a calculation. So you could probably make an argument that this style of computing device was probably sort of the first thing that was around for us to do these types of calculations. It wasn't until the 1800s that we really had more, I wouldn't say modern computing devices, but maybe more sophisticated ones. So Charles Babbage, Ada Lovelace, Babbage in particular from sort of 1800s time frame, had more of a mechanical computer, a difference engine. And again, it's more of a calculator than an actual sort of computer that we would think of today. But the concepts would be very familiar. It's doing some operations on some sort of input. And it's mechanical, so you actually had to like crank stuff. But those concepts, those ideas, just translated from mechanical to more digital stuff later on. Lovelace published a computing algorithm later on as well, and you can actually go look this up and sort of see what it looks like for this difference engine. So there's some really cool stuff there. Once you get into the 1900s, then you start sort of really seeing this explosion, right, of these sort of computers in general. In the 1920s, the computing division was actually just people. So this is I think this is at one of the national laboratories. So this was the computing division, computing section, and it was literally people at things like typewriters. Around sort of World War II, end of World War II time frame, this is when we started getting sort of something that you would recognize as an actual computer. It was programmed using patch cables and switches, and of course, you always hear these things about they were the size of a room and whatever. But this was this sort of actual the start of this style of computing, this sort of World War II time frame, when you're actually sort of building these machines in sort of a more digital sense that actually do many more calculations than you could possibly do on something like Babbage's difference engine. From the 40s on, there's tons of architectures, tons of styles of computers. This is when that frontier of computing really started, when people were really looking at the ways that you could actually do this style of calculation, because it was so pivotal in a lot of aspects of World War II, and then, of course, during the Cold War as well. The integrated circuit was sort of the introduction to general purpose computing for people, for everybody, not just confined to sort of university research stuff or national laboratories or stuff like that. So that was sort of pioneered by Jack Kirby and Robert Noyce. This was in the 60s. So this is why you sort of see the first video games like Pong sort of coming around in the 70s, and a lot more people having computers in like the 80s and 90s. This is why this sort of development of the integrated circuit in the 60s sort of led to that explosion. So here's just a picture of that 8-bit microcontroller, for example. So nowadays, of course, we've got powerful multi-core CPUs in our computers. We've got lots of RAM. We can do billions of operations every single second, way more than even something like 20 years ago, 30 years ago. This is obviously not an exhaustive history. There's a lot of cool stuff that was sort of developed and maybe thrown to the wayside, and at least in some sense is coming back as well. Things like FPGAs are sort of popular again. So definitely the sort of computing goes in cycles, like a lot of things. But I just wanted to give a little bit of background, sort of where we came from. And if you're interested in sort of more of this sort of background and some of the hardware that was available then, I could definitely point you to some of those resources. Okay, so as a programmer, as a software engineer, it is useful to think about what's in our computers. We normally abstract this away, so we don't worry about things like the manufacturers and what exactly the components have. So I'm going to talk a little bit about that. But it is worth thinking about, because in some classes that you're going to take here, things like parallel programming, things like computer organization, it is something that you have to think about. What is the underlying hardware? What is it Intel? Is it AMD? That sort of thing. But for the most part, we just think of them in a few categories. So when we have sort of physical components, the stuff that you would use to build your computer, we got things like a CPU, RAM, hard drives, whatever input devices you have, mice, a joystick, microphone, all that kind of stuff. All those actual hardware pieces that you would buy from like Newegg or something. And of course, there's lots of manufacturers for these. Some of them don't necessarily manufacture things. They sort of pawn that off to other companies, places like Dell and Apple. Some actually do. There's lots of people that make, lots of companies, I should say, that make these hardware components. I guess the big question is then, does it really matter if you have a Seagate hard drive versus a Western Digital hard drive? And typically the answer is no. One might have more certain features than another, but as sort of software programmers at this level, at sort of CS1, CS2 level, it doesn't really matter what your computer has in terms of manufacturing the components that it actually contains. So we think of this as sort of an abstract way. We say the computer has memory. It has a processor. It has a screen, something to display output, or speakers or something. We can read and write to the hard drive, stuff like that. So when you hear me use some of this terminology like memory, or we have a processor in memory, or we're writing to the screen, again, it doesn't matter what screen you have. It doesn't matter what processor you have. It's all going to work the same from our perspective. Underneath the hood, there will be differences, but we're not sort of delving that far, at least in sort of the CS1, CS2 style classes. In addition to the hardware, we've also got the software. So this is our focus. We're focused on running things on that particular hardware. And that means everything. So the operating system that you're using right now, Windows or Mac OS or a Linux version, is all, of course, programmed to run on whatever hardware it's running on. Things like Keynote, where I made the presentation, things like World of Warcraft, that has an expansion coming out, I think, sometime this end of this month or October or something. These are all the programs, the instructions that you're going to be running. And again, that's the focus here. So we're going to learn, how do we tell the computer or the processor or the RAM or the hard drive, how do we tell it what to do? How do we tell it to, say, store variables or run instructions, get it to display things to the screen, for instance? That's our main focus. So in this class, you don't have to worry too much about the hardware part. Again, in other classes, you probably will, but in this class, not so much. So from a high-level overview of the hardware on your system, we've got the processor and the main memory. We normally sort of put these together because they work very closely together. All of your entire program, all the data that you have as part of your program, it's all in the main memory, and that's going to be processed by the processor. We've got some input devices, mice, keyboard, microphone, whatever input devices you would need for your program. So you have storage devices as well. That includes hard drives, but other things here. I know that some of you may have never seen some of these devices before. I didn't put the 5 1/4 floppies on here. Even I didn't use those too much. It was mainly like when I was in like grade school style, we would have the 5 1/4. So lots of different types of storage devices from the entire history of computing. So some sort of device that has some data on it. That's basically what this means. And then of course you have an output device, speakers, monitor, whatever it might be. So that's our high level overview. When you think of a computer as a programmer, this is the sort of picture that you'd have in mind. You got some input, you got some storage devices. It all runs through the processor and main memory to give you some sort of output to your screen, for instance. When it comes to main memory, one of the nice things about Java, and this is something that I'll mention a little bit later as well, is that we don't really have to worry about the memory subsystem. We don't have to worry too much about RAM. That's not true for all languages. So in a class like parallel programming, we actually think a lot about memory. We actually have to sort of manually do things with our computer memory. So I just want to give you a basic look at what computer memory is, and sort of a high-level overview of how it looks. But it's not something you'll need to use in Java for various reasons that we'll discuss later on. So when you think about your RAM, so you might have 8 gigs or 16 gigs or more as part of whatever computer you have you're using right now to view this. In your memory, you've got various addresses. Every sort of location, every byte, which is 8 bits, so 8 ones and zeros. Every byte has its own address, just like a mailing address. So they're all unique. And certain data types, so things like numbers or letters, they take up a certain amount of memory. So for example, here I've sort of colored this one green. This would be 4 bytes starting at address 0. And that might represent a number. Now it could have lots of ones and zeros in here because it's a binary representation, but it could represent a number when you say print it out to the screen. And there are lots of different types of data, and we'll get into variables next week and sort of talk about this, but this is how they're laid out in memory. Anything that you run when you run a program, when you write a program, you're going to have data in memory, and it's going to look like this. So here we've got, say, 1 byte at address 4 here, and we got 2 bytes at address 5. And again, they just represent different things, numbers, letters, that sort of stuff. So from sort of a high-level overview, this is what's going on in your main memory. So when we write a program, when I sit down at my computer, I use Eclipse or some other sort of application to actually write some code. How do we run it? That's one of the big questions to sort of start off with. How do I write some code and then get it to actually run on my computer? So the CPU itself, it doesn't know anything about Java syntax. It doesn't know anything about how to run those instructions that I'm going to end up writing. There's a process to this, to go from something that you can read, something you can sort of visually look at and say this is what the program's doing, to something that the CPU can actually understand. So does your CPU know how to run Java code? Absolutely not. So the process sort of looks like this. So here's that high-level overview. So we got our data, whatever input we have, our processor, main memory, and our output. Your program will get loaded into main memory. So that's how you actually run your program, but the instructions are not like the text that you write. So the processor doesn't directly understand any of that stuff. You use what's known as a compiler to make your code CPU readable. Now, Java has a compiler, and I'm going to show you what that looks like here in just a second. So your compiled program, where you take your sort of English written code and turn it into something that the CPU can read, that's the compiled program. That's what gets put in main memory. And then your program runs with whatever data and input and whatever you need. And then you get your output. So there's this process that any language has to go through. So the compiler is what turns your source code. This is what you write. So whenever you hear somebody talk about, oh, I got to go mess around with my source code, or my source is up on GitHub or something, that's what they're talking about. They're talking about the code that you write. We need to turn that into the machine-readable code. And the program that does that is the compiler. So you have compiled code. Now, the interesting thing is that compilers, they're of course programs too. Somebody sits down at Oracle or something, and they actually write the code to do the compilation. So these aren't magic, although I will admit compilers can act like magic sometimes, for sure. But they actually do have bugs and issues and stuff. Now, we're not using any sort of fancy features of a new version of Java or something, so we're not likely to run into any sort of compiler issues, compiler bugs or something. But if you're using sort of state-of-the-art, brand new features that a language has, it's very possible you run into bugs. And this is something that just sort of working a long time doing this sort of software stuff, I have run into compiler bugs where you literally email the guys that make the compiler and tell them, hey, there's a problem. Here's sort of a small test case that illustrates the problem, and they come out with updates that fix the issues. So compilers, again, they're just programs too. They're just somebody that was like you guys when they started when they started up college. They're now writing compilers. So they definitely can have issues as well. So don't worry about the code that's actually here. This is something that we'll do later on. But let's say you had some source code, so sort of English readable stuff. You send it through the Java compiler, and it gives you Java bytecode. We're going to talk about this because it's a little bit different than what I've been explaining. It's not exactly machine readable. The Java compiler is called Java C. That's the name of the program. When you install the JDK, so this is something we talked about last time. When you install the JDK, this is one of the programs that you get. So the Java development kit from Oracle, or if you get like Amazon Corretto or something, one of the sort of Java versions, you will get Java C. On Windows, it's javac.exe. So this is the program that actually turns the code you write into something that, for most purposes, you can think of as being machine readable. If you take me next semester for CS2, I'll probably ask this question again, and I'll probably ask you guys, do you remember what the compiler is? Because you won't actually deal with this directly. Eclipse is going to handle this stuff for you. But under the hood, this is what's actually happening. You are using an actual compiler. All right, so when it comes to Java, the bytecode, that stuff that Java C turns your source code into, it is different than machine code compiled by other languages. So things like C, Haskell, Fortran, C++, a lot of languages. You translate the source code directly into what the CPU can understand. So for something like the parallel programming class, I use C or C++ or Fortran in that class. For a lot of other stuff that I program, I'll use C++ or potentially some other languages. So in that case, the compiler gives you directly an executable, something I can double-click on or I can run in the terminal or something. In Java, that's not actually the case. The Java bytecode is run on the Java virtual machine, the JVM. The JVM is just another program. It's a middleman. It interprets your bytecode and translates that into something that the CPU can read. So it's like an extra step compared to something like C or Fortran or C++ or something. It's an extra step in there. You go to bytecode, and then you run on the JVM, and that bytecode gets turned into CPU stuff. So then the question becomes, why use a middleman? Why use this JVM? The reason is, and this is what makes Java very, very popular, especially when it sort of showed up in the 90s. The program can run on any computer that has a JVM installed. That's the key. So if I write a Java program and I have my bytecode and I give you my bytecode, it doesn't matter what operating system you're using. It doesn't matter what hardware you're using. You could be using an ARM CPU, which is very different than, say, an x86 Intel CPU. But it'll still run as long as I have a JVM on both machines. Any machine that has a JVM. So your phone, for instance, would have a JVM. Raspberry Pis could have a JVM. Windows, Mac, Linux, all of this stuff has JVMs that are able to run. So hardware and OS doesn't matter. There's no dependencies there. That's what makes it powerful, because if I were to create a C program and compile it on my Windows machine and I gave it to you and you were running a Linux machine, it would not work. It would not run properly. So that's where the power comes from. That's why there's this middleman. So this is something that's sort of worth considering. It causes a little bit of overhead. So Java typically is not as fast as sort of other compiled languages like C or Fortran or something, but the cost of that, the cost of that, it might be sort of overwhelmed by the flexibility that you get. Okay, so I'm going to run through the whole process to create a very basic Java program. Now, I know that not all of you might have the JDK and Eclipse sort of installed and running. That is something that we're going to be working on tomorrow during lab. So if you don't have Eclipse running, if you don't have the JDK installed, you haven't sort of looked at PA0 yet, that's perfectly fine. Tomorrow during lab, we've got the 2 hours. I'm going to run you through the entire thing. And then if you have any issues, if there's any sort of problems getting accounts created or some of the Java stuff running or submitting the assignment or something, we can certainly work it out then. If you've already installed Eclipse and you have it all sort of running, especially if you've done this sort of stuff before, then you could feel free to follow along. Otherwise, we will be doing stuff like this again tomorrow during the lab time. So we're going to run a very simple Java program. And first, I'm going to give you, some of the sort of anatomy stuff related to this. And then I will go over to Eclipse and sort of show you what you'll see when you first install it. So the first thing that I want you to note, and this is something that's going to be very common in a lot of languages as well, is that we have a name for our code file. And that name for the code file is actually required to be the name that you put here in your code. So we're going to have something called public class and then a name. So the file itself, the actual file on your computer, needs to be named that, whatever here with all of the correct capitalization and stuff, .java. So when you name a file, when you create a new file in Java, you want to name it the same as what you intend for this name to be here, the highlighted version of the name. Once you have a file ready to go, you actually don't need Eclipse. So this is not something that you're going to actually have to do, but you don't actually need Eclipse or any program at all other than just something like Notepad to write a Java file, because you can do everything in your command prompt or in your Windows terminal. Things like doing the compilation. You say Java C and then the name of the file. And then you can just run the file using the JVM. The JVM is just Java. So there's the Eclipse is not doing anything special. So when we get to Eclipse, when I'm showing you what's going on, under the hood, it's just doing these console commands. It's not doing anything sort of magic to get this stuff to run. I have another thing here. This is something you might have to do if you want to try this. So if at some point you say, okay, I've been using Eclipse for a while, I want to try doing this console thing, see if I can get this to run without using something like Eclipse. And this is basically the way you do it. You compile, and then you run on the JVM. In order for this to work, you do have to have the JDK installed, because that's where Java C comes from. So that's why I have you download and install the JDK. Even if you have a version of Java already, let's say you have Java on your computer because you've run other Java applications. The JDK has Java C. A regular sort of Java install will not have Java C. So that's something that you might have to consider. As far as the origins of Java are sort of concerned, it was developed in the early 1990s. At this point, I was pretty young, so I didn't get into Java or anything. I was just doing basic stuff on that pre-computer PowerPad. It was developed by James Gosling, Sun Microsystems, which eventually became Oracle or was bought out by Oracle, all that sort of corporate stuff. It is a C-like language. It borrowed a lot of stuff from C++. So if you ever hear sort of me or someone else say it's a C-like language, then you can be pretty sure it's very similar to something like Java. So Java is very C-like, just like C# is a very C-like language. There are others as well, things like Rust and stuff. It depends on the language how much they take from sort of C or C++. But it has some enhancements, some things to make programming easier for sort of people in general. It's considered, for the most part, a high-level language when you consider things like C++ or C to be a low-level language. So it has lots of features that make it easier. We'll look at some of those features, and as you sort of learn more about programming in general and maybe program in other languages, you will sort of start to see that, oh, Java, I can do that in one line. Or Java, I don't have to do that at all. Whereas another language, I have to write a few lines to deal with it. So you'll start to sort of see that as you learn more languages and sort of see more stuff. Low-level languages typically do things like provide direct access to memory. So a language like C or C++, you have direct access to the memory. You can actually manipulate memory on an address level. So the addresses that I showed before, you can actually go to an address and change a value in an address. Whereas something like Java, you can't sort of explicitly do that. Java sort of handles it for you in the background. So basically any programming language is going to follow the stuff that I have on this slide. But of course, for us, it's going to be Java. So there are some quirks that we'll see as we go through this semester and as you go through something like CS2. But like any language, Java is written with a fixed syntax. So if I talk about sort of syntax in the future, you have a syntax error, or you need to think about the syntax you're using. It's just the grammar. When you're learning a language like English or potentially a second language, you have to use proper syntax so that the statement that you're saying or the statement that you're writing makes sense. Otherwise, it just sort of looks like gibberish. So it's the same idea for a programming language. The syntax is just going to distinguish between something that is going to work and something that is not going to work, that's not going to make sense to Java C, to the compiler. There's lots of special keywords, and there's lots of special characters that mean very specific things. Sometimes in different contexts, they can mean multiple things. So this is where some of the confusion can come in. And this is why practice is super important. Because getting to understand what these keywords do, what these characters do, where you should use them, it's all part of learning how to program. So these keywords, these characters, they're used to tell the computer what to do, along with sort of other names that you can create for yourself. Generally, in whatever program you're using, so something like Eclipse, whatever program you're using to write Java, keywords and characters and stuff, they're generally highlighted. This is what makes using something like Eclipse, or depending on sort of the languages you've used in the past, things like maybe IntelliJ or VS Code or Visual Studio or something, they're highlighted. It makes it easier for you to quickly pick out certain things. So we'll see some highlighting today when I flip over to Eclipse. So Java in general, and programming in general, it forces you to think logically about executing instructions, because that's how the CPU thinks. And really, when it comes down to it, the math classes that you're taking, for instance, they force you to do the same thing, step by step, following a strict order. When you take a derivative or when you do an integral or something from a calculus class, it's the same type of process. This is why computer science and math are linked so closely together. It's because of this sort of logic that you have to think about when you're doing math and also when you're programming. So this is stuff that as we go through and do examples and as you get practice, you'll get better and better at thinking about the steps that you have to do in order to solve a problem. And the examples that I do during class, some of the live programming stuff that I'll do, I'll give you my insights, my sort of thinking, what I'm thinking when I'm trying to solve a particular type of problem. And hopefully that will help sort of gain some intuition for you throughout the semester, and if you take me for CS2 throughout next semester as well. All right, so let's look at the anatomy of a program. So here is my program. It's called Hello World. So of course my file is also named hello world.java. So that's something that I do want you to remember. We have a bunch of stuff here. This is an actual program. This will work if you put this into a project in Eclipse. This will run properly. There's a lot of stuff here. There's keywords. The keywords here I've sort of mostly highlighted as sort of blue. I didn't highlight string here, but I mostly highlighted these as sort of a blue color. The keywords here: public, static, void, string, class. Some of them are capitalized like string, some are not. Don't worry if you don't have any idea what these do. By the end of the semester, everything in this program you will have seen and hopefully understand. So don't worry if you don't know all this stuff yet. I just want to point out that all of these things, they mean something important. Same thing with stuff like characters. So we got some periods. We have various styles of brackets. So we have parentheses and square brackets and curly brackets and quotation marks and semicolons. They're all here. And they all do mean something specific. And this is just the syntax. This is how do you make a correct sentence in Java. So we'll learn about what all of this stuff means over the course of the semester as well. So we are going to do a little bit of sort of hand-wavy stuff. I'm sort of going to tell you a couple things that this is the way it is for now. And then later on in the semester, that's when we'll learn about why this is the way it is. All right, so let's talk about what the lines do. So we have this first line, public class hello world. For now, think of this as telling Java that you have this file, it has Java code in it. It has executable code that we're writing. We will talk about what this actually means, what this sort of really means later on in the semester. But for now, just know that it's a file called helloworld.java that contains some code for us. So again, remember, the file name in this case will have to be helloworld.java. That is one of the sort of strict requirements that we have to follow. The next line that actually has some stuff in it, that I have a little bit of sort of white space here, but the next line that has some stuff in it here, this is public static void main, and then it has some parentheses and string and some other sort of square brackets and args and stuff like that. This is something that'll be very common. This is basically just a line right now that you can always put after whatever this public class line is. So main is where your program actually starts. Think of it as saying, start here. Anything between the opening curly bracket and the closing curly bracket for this main thing. So we have an open curly bracket and a closed curly bracket. Anything in here is what's actually going to execute. So I'll show you how you can actually automatically create this and sort of have a skeleton ready to go in Eclipse today. And then, of course, tomorrow as well, sort of show you some of this stuff. But for now, think of this main thing as start here. All right, the very last one is how we can print. We can print to the screen. We're actually going to print to the console, so it'll show up somewhere in Eclipse that we'll talk about. But this is your standard print. So system.out.printf, and then we have some parentheses, we have some quotes, and we have hello world in here. So this is going to print everything in the quotes, hello world, to our console. So we will see that when I flip over to Eclipse. So that's what this program does. It's your very basic hello world program. Any language that you sort of learn or that you first start learning, there will be an example like this. It's a hello world in C, or a hello world in Java, hello world in Python. These are typically the first programs that you write. Some are more complicated than others. We will actually write, if you take parallel computing with me, we'll write a parallel program, this sort of a parallel hello world. And it's much more complicated, but it's sort of your starting place for examining how to actually use the language. All right, so I'm going to flip over to Eclipse. The next few slides are sort of how you start some of this stuff. So I'm going to go through them live, obviously, but they are part of the slides as well. So let's say you download Eclipse tonight or something, and you want to sort of follow exactly what I did today. You don't necessarily have to watch the video again or something. You can go to the slides because I have them laid out so that you don't have to watch the recording if you don't want to. So I already have Eclipse open. This is 2020-06. So it's from a few months ago. And this is typically what you're going to see when you start. So once you get everything started, there might be like a welcome screen or something that pops up that you can close. But essentially, you're going to get to this point. Typically, I close a couple of these panels. So there's a panel. Let me turn on the spotlight thing here. There's a panel over here called Task List. I typically close that one out, and the outline, I close it out as well. We don't necessarily need it at the moment. Your code is going to go in this sort of top block here once we create a file. Down here, there's a few tabs and stuff, but the main one to worry about is the console. So any output that our program does is going to show up in the console here. And any projects that you have, any Java projects that you create, are going to show up over here in the Package Explorer. So what we can do to create a project, so this is sort of the two-step process to actually get to an actual Java file we can work with, is say new Java project. So I'll go File, New Java Project. And there's a bunch of stuff here. Most of this you're not going to have to change. In fact, you just have to give it a name. So I'm going to give it a name. I'm going to call this Hello World. Obviously, you can type it however you want to. There are some options for which version of Java to use. If you only installed one version of Java, then you don't have to change anything. If you have lots of versions of Java installed and you want to use a specific one, you may have to mess with this a little bit. As you can see, it's going to use Java 11. So for this class, I'll be using Java 11 for basically the whole thing. Again, the download for this, if you don't want to create an Oracle account, the download for this is on Blackboard. You can go in and it downloads it from my Google Drive. So you can go in, you can grab that, you can grab 11, you can grab 8. There's links for both of them. Or you can go to Oracle and grab sort of whatever version you want to from them. So I'll be using Java 11. And at this point, I don't have to do next or anything. I can just say finish. It's going to ask me if I want to create a module info file. Typically, this is not needed. This helps sort of package stuff up. So we don't actually have to do this. Some of this depends on your version of Eclipse. If you're using an older version of Eclipse, it's probably not going to ask this, but it will on 2020-06. So typically, I just say don't create, but it's not going to cause any problems if you actually do. So I'm gonna do that. I had a quick question that said that some of you might be wondering, is there any reason to use a specific Java version over others? So as more Java versions come out, and this is sort of the general sort of Java version thing, you do get new features. So anything sort of pre-Java 8 is sort of mostly considered sort of an older Java version, where you didn't have a lot of the sort of nice features that were added in Java 8. And in fact, we use in this class and in CS2, we use features that only first existed in Java 8. The language has evolved since then, of course. So Java 11 has more specific features than Java 8, but we don't specifically use any of them in CS1 and CS2. So overall, the Java versions are going to give you different features. For this class, the difference between 8 and something like 9 or 10 or 11 is going to be negligible. In the future, you might read that something like Java 12, right? Java 12 comes out, and you might see a feature and go, that's actually really cool. I could really use that. At that point, then you know that Java 12 is like the minimum version that you want to use. And then, of course, you would use that for all your projects and all that kind of stuff. So keep that in mind. There are feature differences, and that includes things like syntax differences and stuff like that, additions and maybe removals of stuff from the language. But again, for our purposes, 8 and 11 or 9 or 10 are going to work just fine for what we're going to use for CS1 and CS2. The biggest difference that you'll actually encounter between 8 and 11 for CS2 is it's a little bit more complicated to get JavaFX working correctly with Java 11. With Java 8, it's very simple. With 11, it's a little bit more complicated. So hopefully, whatever professor you take will sort of be able to handle that. They should be able to. I can certainly help you out with it. If you take my class and you realize that you can't get JavaFX working right or something, I can certainly help you out. It's just a couple of extra steps. So that's the biggest difference that you'll probably encounter at this point. All right, so I created that project. So file, new Java project. So it showed up over here in the package explorer. So now I have this Hello World project, and I have a little arrow that I can click that brings it down. I don't have to mess with any of this stuff. There's this sort of system library thing here that has a whole bunch of crap in it. You don't have to worry about that. The biggest thing to notice is that you have this folder here. It's called source. This is where your files are going to go for your project. Right now, there are no files in the project. This is just an empty project for Java. So what I'm going to do is I'm going to right-click, and you can do this on the actual project or on the source folder. It doesn't actually matter. And I'm going to say new, and I'm going to say new class. Remember what the first line of our program was. It was public class and then the name of the file. So we're going to make that class. That's the file that we want to start with. So I'm going to click on this. I'm going to say class. I have to give it a name. You can name it whatever you want. It doesn't actually matter. I am going to name it Hello World, so it's going to be the same name as the project. But again, it doesn't matter. You can name your projects whatever. You can name your class files whatever. And then I am going to do something with one of these options down here. So there's a little thing here with some checkboxes that says, which method stubs would you like to create? The only one that's checked is inherited abstract methods. That's something that we'll learn about much later. But there's this first one here that says public static void main, and then it has the string args thing. This will automatically put that in for us if I do a check mark here. So I'm going to say finish, and we get our file. So notice in our source folder, we have this thing that popped up called default package. We don't have to worry about that at the moment. And then we have our file, hello-world.java. So we have public class hello world. And then because I did that check mark, it also generated this for me automatically, this public static void main. So typically when you create a new project, that's what you're going to want to do for now. Have that little check mark and make it so it puts this in for you. Otherwise, if I didn't put that check mark in, it would just look like this. So now we can start adding in our code. So I'm going to delete that line there that I automatically put in. So I sort of have just sort of an empty file with a main. That's basically where I want to start. So the anatomy of a program thing that I showed you was this, system.out. Notice how stuff pops up. We get a whole bunch of stuff popping up for us. This is to help you see what's available for things like autocomplete. So if I put another dot, so you have a whole bunch of things here. This is a list. You can scroll down it and stuff. If I start typing in print, it actually shows me all the possible things that I can use for print. This is why using something like Eclipse or IntelliJ or some other sort of editor like this is very useful. You don't have to remember all the syntax for all the possible versions of print that you can use. You have them right here. And if I look at them, it gives me a little description as well. So these are sort of helpful things that an IDE, an integrated development environment, can help you do to help you code potentially faster. So the one we're going to use is printf. And let me type that in again so I'll show you what it does if you use an autocomplete. So I do printf. And I sort of start typing it in. It actually creates some stuff for me. So it has format. This is the thing I'm going to actually print out. And it has this args piece. We're not going to use that at the moment, but we are going to fill in this format piece. So I'm going to put some quotes, and I'm going to say, hello world, and maybe an exclamation point, and I'll close the quotes. And then this args piece here, I don't need that. The very last thing I need to do is put in a semicolon. You're going to put semicolons everywhere. Almost every single line in your code will have a semicolon. Now, in this case, notice that there are no semicolons after the first line here and after this main line. And then there's various reasons for that that we'll learn about later. But most of the regular lines in your program are going to have a semicolon at the end. Not all languages do this. If you've programmed something like Python before, you'd obviously don't have to put stuff in there, put that in there. Things like Fortran, you don't have to. In C or C++, you do. So these are just the differences in syntax between languages. The semicolon basically says, this is the end of the line. That's really what its main sort of purpose is. Okay, so at this point, you would, of course, want to save. And then to run the program, we'll go back to just the, we can just spotlight on here. To run the program, you have a couple of options. The one that you're probably going to use most if you don't use the keyboard shortcut is up here. It's this green circle with the sort of triangle for sort of the run symbol, something that you'd see on a TV remote or something. So it's this one right here. So if I click this, it's going to run. And in my console, see it says hello world. So a lot happened there. There was a lot of stuff that just happened that Eclipse did behind the scenes. It used Java C. It compiled my written code into Java bytecode. It then used the Java the runtime environment, the JVM sort of specifically to take that bytecode, run it on the CPU, and print my output to the console. So a lot of stuff happened behind the scenes, but luckily for me, all I got to do is click the run button. So these, again, are some of the benefits you get from using something like Eclipse or IntelliJ or something like that. As in principle, you could do this whole class in something like Notepad and the console. But this is going to help you out a lot more than using something like Notepad or something like the pre-computer PowerPad with only 4 lines that you can actually see. Okay, so going back over to the slides, most of this is sort of the stuff that I just mentioned. So create a new project, create a new class, gives you sort of a file. We'll write some code in there, the sort of hello world thing. If you see a line that begins with // So let's go back over to Eclipse. If I put in a line here and I start it with this //, Eclipse is going to change this. It's going to change the color. This is a comment. The compiler, the Java compiler, doesn't consider this to be anything at all. It actually just trashes it when it creates the actual bytecode. This is for you and for me, and will be part of your grade. So that's something we'll get to when we talk about some stuff tomorrow in lab. You can put this in to basically say anything you want. So for this, if I was sort of starting out, I might say prints hello world to the console. That's relatively self-explanatory just by looking at the print line, but comments are meant to help you if you come back and look at the code, or to help other people, specifically if you're working in a group. So you will be graded on sort of comment usage, and I'll show you sort of proper sort of comment stuff as we go on sort of for PA0 and for PA1, so you know what I'm looking for in terms of comments. But any line that starts with // will be sort of changed to a different color depending on your color scheme, and will be sort of ignored by Java as a whole. Otherwise, the rest of the lines and the rest of the words that you see here, they're all highlighted. So that public class and public static void, they're highlighted a particular color because they are keywords. They mean a specific thing. So this is how Eclipse sort of tells you what's going on. If you notice something that's not highlighted or not highlighted correctly, maybe not highlighted like you're used to, then there might be sort of an error in the code. So we're going to talk about that too in just a second. All right, so back to the lecture. Yeah, so comment stuff, and there we go. Running the program, again, you can go up and you can click the button, you can click the run button, or there's a run menu where you can go to the run menu and then click run. There's keyboard shortcuts as well. Control F11 will have you run in Windows, and Shift Command F11 will have you run in OS X. So lots of ways to run the program. Use whichever way you like. Most of the time, I will just be clicking the run button. That way, I'm not sort of using a bunch of keyboard shortcuts or something that make it sort of more difficult for you guys to tell what I'm doing. So I'll probably just click the button most of the time. All right, and then we talked about this. What happens when you click run? There's all sorts of stuff that happens behind the scenes. If you haven't saved, let's say you try to run the program and you haven't saved yet. You haven't done like a Control S or a file save. So right now, I haven't saved the program since I added this comment. So if I click run, it's going to bring up a window. And it says save and launch. So it's going to ask me, basically, I need to save this before I run it. Typically, if you see this window, it's going to tell you what files need to be saved. And you can do check marks and stuff if you have more than one file. And then you can say OK, and it will save it before it runs it. So if you see this sort of window pop up or something, even when I'm programming, I'll forget to save sometimes before I run. Most of the time, I'm just saying OK to save the actual file itself before the run takes place. So it will ask you that. So you do have to save before you can run. And then, of course, whatever output you have, it's going to show up in the console pane. Or, if you're using JavaFX in CS2, you might be able to do stuff on an actual sort of Java window. But for this class, it's all going to be in the console pane at the bottom of our Eclipse GUI. All right, so let's say you make an error. Now, I know you guys aren't going to have any problems with coding errors or something, but I do have sort of errors all the time when I code. So when I make a mistake, Eclipse and Java, they try to tell you what's going on. They try to tell you even before you run the program that there might be a problem. So I'm going to go in and I'm going to misspell system. So I'll just swap a couple of the letters. And the main thing that you're going to notice is that immediately the look of the program changes. So I'm going to come in here and let's just switch like the T and the S or something. So we no longer have highlighting on the system out printf like we had before. And we also have a squiggly red line underneath the system. There's a couple of other places that this has changed as well. I'm going to save this so that it's sort of a saved file that doesn't work. We have the squiggly underline. We have a thing over here in what's known as the gutter. So the gutter is the space immediately to the left of the lines. Some programs, it's immediately to the right. It just depends. So we have a little thing here in the gutter that pops up with a little red X. or a little X surrounded by red. And then over here in our project even, we have a little tiny little symbol that sort of shows that something is wrong. So all of these sort of indications mean that something is wrong with my program. And when it's red like this, the program is not going to run properly. So the best way to figure out what's going on is whatever's highlighted. So whatever's sort of underlined like this. If I hover over that, it's going to tell me what the error is. Now, it might be a little small. I did change like text sizes and stuff, but the pop-up texts don't always change. This says, the first little thing underneath this says, system cannot be resolved, or my misspelling of system cannot be resolved. That's the actual error. That's the actual issue in my program. Now, Eclipse tries to be helpful. So all of this stuff down here, the sort of 11 quick fixes available, are trying to help me fix this problem. Typically, if you just misspell something, you're not going to want to use these. There actually is one of these that actually will fix the spelling of system. But most of them, particularly at the top, are like create a class, create an interface, create a constant, create an enum, create a local variable. So typically you're not going to want to use these for most of the time. I'll show you cases where you will. But for now, since we sort of aren't as used to Java at the moment, at least most folks aren't as used to Java at the moment, you'll want to sort of leave these be and just realize that the thing that's underlined is probably incorrect. So you lose the highlighting, but you can hover over. Now I can also go over to the side, to the gutter here, and I can hover over that as well. It doesn't give me as much info, but it does pop up and say system, my misspelling of system cannot be resolved. So that gives me an indication as to what has happened. If I try to run this, so let's say I try to run it with an error that is sort of with this sort of error in place. If I run it, the first thing that happens is a window like this. Typically, you don't want to say proceed. This says errors in workspace. Errors exist in the projects, proceed with launch. Typically, if you see this, you're going to want to say cancel and fix the error. If you don't, there's two possibilities. Either it's going to run and look like it worked. If that happens, it's going to be very misleading because typically that means it used a previous version of your code that did work and actually just ran that. So you want to be careful when you see this errors in workspace. If it does actually try to run this, like in this case, you might get some red text as well. So this says, my misspelling of system cannot be resolved. And this is an unresolved compilation problem. So Java C did not work properly. So it tells me what the problem was. This is the same text that showed up when I was doing all the hovering stuff. It also tells you where it happens. This is super important. Anytime you see a bunch of red text from something that essentially your program crashed, did not work properly, at the bottom of that red text will typically be information about where it occurred. So this happens in hello world.main. So here's my hello world, here's my main. It tells you the name of the file, hello world.java, and this right here, the number that happens after this colon, is the line number. It happened at line 6. So you get a lot of information from the console. We are going to look at using the Eclipse debugger in probably one of the labs in the next few weeks. But for now, if you have the program and you write something real quick and it gives you some red text like this when you try to run it, it does tell you where it actually happened. So if you see that system, my misspelling cannot be resolved at this location. So definitely want to use that to your advantage. All right, let's see in the slides here. A few things here about misspelling, hover over the icons, and all of that. Okay, so let's talk about that system out printf thing. When you want to output text to the screen, my recommendation for most of the stuff that you write for this class is to use system.out.printf and then the parentheses. This is something that's built into Java. This is a built-in Java method, and it makes it easy to print a line of text. Notice that you don't have to worry about the screen at all. And most languages have, of course, something like this. You don't have to worry about the hardware, the video card, none of that stuff. That's all handled by Java and drivers and stuff in the background. So system.out.printf, that should be your go-to. So syntax is generally always going to look like this, system out printf, and then you'll put some text in there. The text can be in quotes like this, sort of directly putting it in, or as we'll see in the next couple of lectures, you can also use a variable in there as well. The nice thing about printf, the F itself means formatted, so it's a formatted print. The nice thing about this style of print is that you can input special characters by using a backslash to do specific things. So let me hop back over to Eclipse, and we're going to spell system right this time so that our program should work. And I'm going to run it, save it, and run it just to make sure. Okay, here's our hello world. If I put another print in here, so let's just copy this line. If I put some other print in here, and I save it, and I run it, notice how it's all on the same line. This is where the formatted print comes in. And David, you had a question about print ln. So yeah, there's a few different versions of print. So we're talking about printf, I'm going to show you some of these little special things you can do, and then I will mention print line. So I'll show you print line as well. There are a few different versions of print that makes it easier to do some specific stuff, but I'll show you specifically why as well. So for our printf, everything's on the same line, no matter how many sort of lines of stuff I have. If I want a new line, let's say I want these to be on separate lines. I want hello world to be on the first line, and this hi, I want this down right below. Then I would need to throw in a new line character. So in the slides, that's right here, /n or %n. I'm going to have you guys use %n. /n is very common in a lot of languages. I'm going to have you use %n though. The main reason for this is for our assignments. Our assignments, the sort of the tests that you can run that we'll talk about more tomorrow, they have a problem with the /n, particularly on some different operating systems. /n may not work properly. So %n will always work with the tests that we run. So this is just a special character saying, I want a new line right here. So if I run and save, here we go. Now I have a new line. And you can put this anywhere you want to. I could throw another one in before the hi right here, and that would give me essentially 2 new lines. So I have a blank line. And of course, there's other things I can do. I can throw in a /t. That does a tab. Whatever sort of size the tab is sort of defaulted to in the console, that just gives me a tab. So there's lots of these little sort of formatting things that you can do. The benefit here for some of this formatting stuff is printing out, say, a number that you compute in the code. Printf is going to give you a lot of flexibility as to how you do that. So that is why I do recommend using it. But there are a couple other versions of printf, or of print for this. So let's do system out, and I'm just going to do a regular just print, and we can throw something in there. Another greeting, for instance. This is going to do something similar to what we saw before with no sort of new line stuff. It's just going to throw this in. But if I put a %n here, let's watch what happens. It literally prints the %n. So no matter what you put in a regular print, it doesn't read these special characters, where printf does. Then we have another one as well, and I'm going to throw in sort of two prints here to sort of show off what this one does. So David, you asked about print line. Of course, that is a very common one as well. You could feel free to use this one whenever you would like, whenever you'd like to. Let's put in just a hello like this, and I'm going to put in another print right after. And this one I'm going to put in like a %t, and I'll do the this. Okay, so we got a couple more prints in here. Let's see what it looks like. So the tab stuff still worked well. That's good. Notice that I didn't put a new line anywhere in this hello print line, but it gave me a new line. So that's what this print ln, this print line, that's what it does. It automatically puts in a new line. Now, what if we do, say, an actual new line sort of character like this. Now it just prints that out. We should be able to use the /n, however, to get it. So using a %n, which is, again, this is what I recommend for all of your assignments, is %n for new line, because of some of the tests and stuff that you can run. The /n does not always get read properly by the tests. It won't do the %n properly when you do this, or some of the other % stuff. So I do like a %f or something. It's not going to read those, which is some formatting for printing numbers and stuff that we'll get to later on. So print line can be good to use, of course. It gives you that automatic new line. The most flexibility for how you format things comes from printf. So if you're used to using printline, you've used Java before or something, you're used to using printline and everything works out, that will, for the most part, work fine for our assignments. But if you want the most flexibility for how this stuff works, and usually what I'm going to be doing in class is using printf. It's not too common that you'll use something like print, just because it doesn't have sort of any flexibility at all as far as printing stuff out. So those are a few of the options. Again, feel free to use what you're used to, but the tests that are going to be run on your assignments that you will be able to run as well are very picky. So that's something that you may have to fight with a little bit, and stuff that I do fight with as well, into sort of getting the appropriate new lines and spaces and all kinds of other stuff in there. So that's a little bit of sort of intro to printing some of this stuff out. So come in here. If you want a double quote, you do a / and then quote like this. Because if you put in a quote, it just ends the line that you want to print, and then you'll get some sort of error. So if you want an actual quote, you got to use a /. If you want to print a /, then you have to do //. And this is very common. You'll see this in a lot of different languages. So if you have some specific character that you want to print that is sort of a special character in Java, oftentimes you have to put a / in front of it. You can combine multiple pieces of text with the plus sign. This can be very useful when we get to things like variables. So as a few examples, here's a few things that I've sort of printed and sort of just showed you, stuff like hello world, howdy, and like a %n, doing the /t for the tab. But we can also do something like this, where I take sort of one sort of string, one sort of bit of text between quotes, and add it to another bit of text. So if I come over here and I do something like that, let me get rid of all these other ones here. I do this, and I put in a plus, and let's say I close that out. This is going to work, but maybe not like you would expect. Notice that when I run, there's no space here. There's no space between hello and world. So it just jams them together exactly. So if I want a space, I either need to put a space after the O or before the W. So if I do that, save, then I have my space here. The reason why I'm talking about printing stuff out so much is because it is going to be important for your assignments. And we will do more of this tomorrow. The sort of first PA0, getting everything set up, literally has you write this as part of the assignment, the hello world line with a new line. So really, this is PA0 basically done at this point. But it's getting all the software set up and being able to turn in your assignment and all that stuff that we are going to talk about more tomorrow. All right, so typically during class, I'll have some small sort of example stuff where I'll do some live coding. And then at the end, typically I'll have sort of a larger exercise, or maybe a couple of exercises, a couple of smaller ones that you can work on. So with Dan here, what we'll probably do for classes starting next week is I'll break you out into breakout rooms with, say, maybe 2, 3, 4 people, something like that. And hopefully this will give you a chance to sort of talk to some of your classmates a little bit in sort of a less formal environment than sort of asking questions potentially during class. And myself and Dan will sort of jump in and just see if sort of see how everyone is doing. And then usually that sort of will wrap up the class sort of at the very end. So today we're not going to worry about that, since not everybody has Eclipse up and running. Not everybody is sort of ready to go for that sort of stuff. So as far as the exercise goes, I do recommend coming back to this once you get stuff installed, and I'll probably mention that next time. But this is just doing some formatting, figuring out how can you print something to look exactly like I've sort of shown here. because it's going to be important for your assignments. Your assignments, they're going to be very particular as to what the formatting looks like. So something like this, we have hello world, we got a blank line, and what looks like a tab here. There's like a tab between display and text. There's a space before the two. There's a new line that sort of goes down. So this sort of stuff is what you want to think about when you do all of this printing. So using something like printf or printline will be able to get you this style of code. Now, typically on the slides, I do have the solution. So I'm not going to sort of leave you in the dark. If you don't figure it out and maybe Dan or I don't get to you or something, it's not like you're just going to be lost forever on it and you're never going to see the solution. I do put the solution on the slides as well, so you can certainly take a look at this. One of the questions sort of after this is, I use a whole bunch of printfs for this, but can you do it with one line? And the answer to that's yes, of course. We saw the plus that we could do, or we could just sort of keep the string going for super long. And my mouse is going over to my second monitor. Typically, though, that doesn't look very good, and it's a little bit tough to figure out what's going on. So using multiple printfs like this, perfectly fine. It's not going to give you any issues. But you can actually do this with one line. All right, and I did mention the print line. I do have a little pop-up here that mentioned it, but print line is different. And if you're used to using print line, great. You can certainly use it, but printf does give you a little bit of extra flexibility. So that's probably mostly what you're going to see me using during the semester. All right, so since we're just about done today, next time is more Java, of course, and variables. So by Tuesday next time, everyone should have Eclipse up and running, so you can sort of follow along with some of the sort of smaller exercises that I do during class. Make sure that you can sort of compile, run Java programs through Eclipse. We'll get working on that some tomorrow. So PA0 is sort of due next Tuesday. Most people will finish it tomorrow if you haven't already. So we're going to make sure we get Eclipse up and running. And if you have problems, tomorrow is a very good day to sort of meet and work those out. Otherwise, if you have problems over the weekend or something, you can certainly email me and let me know. And as far as turning stuff in, we'll work on that tomorrow as well. And some folks still have problems for like PA1 getting everything turned in. So I'm certainly very lenient for these first few because this is a lot of software to get used to, and sort of the process takes a little bit of getting used to as well. So more Java, start talking about variables on Tuesday, and make sure that you can use Eclipse, which is something that we will work on a lot tomorrow. So yeah, so that is basically it for today. Josh is okay for to have a repository and Eclipse set up on both laptop and desktop. Yes, definitely. So I do have folks that use multiple computers. So if you have a desktop, you have a laptop, and you want to set stuff up to work on both, all you'll have to do with GitHub is just make sure you pull down the most recent version, and you can work on it and push stuff up as much as you want on multiple machines for sure. Okay, so that is it. I will see you guys tomorrow. Yeah, tomorrow, I think it's 10 to noon. You'll use the same link, the same sort of lecture link. We'll just use the same one throughout the semester for both lecture and lab. So yeah, I'll start out lecture tomorrow or lab tomorrow, basically just talking about PA0. I'll run you through the whole process at least once, and then we'll answer any sort of issues you might be having with the whole thing. So that is it. Thank you guys, and I'll see you tomorrow.
Thank you.
Thank you.
Yeah.
Oh yeah, you can jump spam in this game too.